This is 11.9, representations of functions as power series. So what we've been talking about has been some power series and looking at what values of x will make the series converge. So mainly we've been looking at series that kind of look like the sum from n goes from 1 to infinity of c sub n x minus a to the power of n. So something that looks like that. So you might have something in some coefficient here, x minus a to the n. So we were trying to figure out where the radius of convergence was. So let's take a step back and remember what exactly were geometric series. So if we remember what geometric series were, geometric series kind of look like this. So you had the sum from n goes from 0 to infinity of a r to the n. And actually what we said in geometric series, it seems like such a long time has passed since we talked about geometric series, but you can actually find the sum. We can say that it converges, but we also know that we can find the sum as long as r is less than 1. If we know that r is less than 1, the sum of this is just going to be the first term divided by 1 minus r. That's what we said was the sum of this geometric series. Now what we're going to do is that we're going to extend this to power series. Okay, so let's say we had a power series, okay? And what we have is the sum from n goes from 0 to infinity. Okay, and what we're going to do, we're going to say a is going to be equal to 1, and then my r is going to be equal to x. So I'm just going to plug in 1 for a and x for r. So we're going to have x to the power of n is going to be equal to, well, let's plug it in, 1 over 1 minus x. And that's under the, provided that x is less than 1. So basically, I can choose any polynomial, okay? So this polynomial, x to the power of n, is going to be equal to 1 over 1 minus x, provided that x is less than 1, okay? So what you can say is that we can represent the function f of x equals 1 over 1 minus x as a power series. And that power series will be the sum from n goes from 0 to infinity of x to the power of n, and they will converge when x, the absolute value of x, is less than 1. That is really cool. That is really powerful because we've been dealing with functions before. All of our lives in our math classes, we've been dealing with f of x is equal to 1 over 1 minus x, or f of x equals x squared, or f of x equals cosine of x. Okay, we've been dealing with those functions, but now we are able to represent every single function, well, at least for right now, this particular function, as a power series that looks like that. Okay, so that means that I can represent these functions, okay, as something with a sum, which is actually really, really cool. And you'll see all the properties that come along with it. Okay. So let's try to figure out if I can try to find some function that kind of looks like 1 over 1 minus x, then I can go ahead and represent it as a series function. Okay, so let me go ahead and give an example. Okay, so here's my example. So find a power series. So find a power series representation for the following function and find the interval of convergence. Okay, so that's what we want to be able to do. Okay, so here is my first one. So let's say we have g of x is equal to 1 over 1 plus x cubed. Okay, so I want to represent this function as a series, okay, and see where the series is going to converge. So what values of x will it make it converge? Okay. All right, so notice that this guy does not look at all like this, okay? So what I need to do is I need to fix this, okay? I need g of x to look like 1 over 1 minus x. That's what I need it to look like. So right now, if I say f of x is equal to 1 over 1 minus x, I can represent this function as a series, summation from n equals 0 to infinity of x to the n. But that's not quite what I want, okay? I want g of x. G of x is equal to 1 over 1 plus x cubed, okay? So how can I fix this? Well, first of all, I need to fix this negative. So how can I change this to a positive? Well, I know that a negative times another negative give me a positive. So I can write it like this, okay? Because then the negative and the negative is just going to go away, okay? And notice that now what I've done is that I kind of said that this, I changed it to a negative, and now this x is being represented by this x cubed. So that means wherever I see an x, I'm going to just plug in it a negative x cubed. So let me go ahead and write this out. So this is good. Now this kind of looks a lot like this, a little bit, okay? So I'm going to write it. Summation from n goes from 0 to infinity, okay? Now, this x comes from this x. So whatever I plug in there has to come from whatever's inside of the parentheses. And inside of the parentheses is a negative x cubed. So we're going to put a negative x cubed in there. And then provided, okay, now remember this guy over here was that x, the absolute value of x, was less than 1, okay? Now in this case, you're not going to have the absolute value of x because x here was based on what was on the denominator. In this case, what's on the denominator? A negative x cubed. So negative x cubed is going to go in here. Okay? All right. So here's the negative x cubed. Now what I'm going to do, I'm going to box this thing. I'm going to do this one a little later. Okay? Because this is going to help me find my interval of convergence. But for right now, let me go ahead and figure out what the power series representation will be. Okay? So this is going to be equal to, so I'm going to have the sum from n goes from 0 to infinity of negative x. Now this 3 and this n is going to be 3 to the power of n. Okay? Now something that I can do now is I can take out this negative. So I'm going to have the sum from n goes from 0 to infinity of negative 1 to the 3n x to the 3n. Okay, so taking out the negative. And then negative 1 to the 3 is just going to be negative 1. So I can just write it as summation from n goes from 0 to infinity of negative 1 to the n x to the 3n. Okay? All right, and that's it. This is the power series representation of this guy. So this means if I were to expand this thing out and add all those terms together, it's going to be basically the same thing as having this 1 over 1 plus x cubed. Okay? Now we haven't figured everything out because we need to figure out, okay, this will only work as long as x is between what numbers? Okay, well, now this is when this box part will come in. Okay, so now we're going to look at the green part because we found the power series representation. That's what we were looking for. Now let's find the interval of convergence. So the interval of convergence is going to be negative x cubed less than 1. Now the absolute value of a negative number is just going to be a positive number. So you're just going to have the absolute value of x cubed less than 1. I can take out the 3 out. Okay, then take a cubed root to both sides. So you're going to have the absolute value of x is less than 1. So that means that my interval of convergence is going to be x is between negative 1 and 1. Okay, notice that you don't need to check the endpoints because if it equals 1 by geometric series, this is not going to converge. So by geometric series, this is going to just, you don't need to check the endpoints. Okay, all right, and that's going to be your answer. Okay. So now, let's do another problem. Now that we kind of got the gist of it. So let's say we have another function, h of x, and we have 2x squared over 1 plus x cubed. Okay, so now what we want to do is we want to make sure that we find the power series representation. So I know that the power series representation of f of x, which is 1 over 1 minus x, is equal to the sum from n goes from 0 to infinity of x to the n, provided that the absolute value of x is less than 1. Okay, so now this is not what I want. What I want to know is for this h of x, which is equal to 2x squared over 1 plus x cubed. Okay, so notice I can fix the x cubed on the bottom, kind of like how I did it before, 1 minus negative x cubed. Okay, I can do it that way. Now what I'm going to do is I'm going to move this guy, this denominator, over, so 2x squared times 1 over 1 minus negative x cubed. Okay, so just moving it over, putting it over 1, and now I can go ahead and represent this guy as the power series, because now that guy is going to look a lot like this guy. Okay, so what is this going to give me? Well, this guy right here is not going to do anything. This stays the same. And now this guy is going to be the power series. The sum from n goes from 0 to infinity. And then you're going to have this negative x cubed to the power of n. Provided that, now we're going to plug in this negative x cubed in here. Okay, so this is going to be for later. And we actually already know what this is. Okay. And now this is just what we just did before. So it's just going to be 2x squared. We just figured that one out. That was just going to be the sum from n goes from 0 to infinity of negative 1 to the power of n, x to the power of 3n. Okay. Now we need to fix this thing because we need to plug that in inside. Okay. So I'm going to plug it in. So summation from n equals 0. So let me bring in the 2. Negative 1 to the n, and I'm going to bring in the x squared, x to the 3n. Okay, so now this is going to give me the sum from n goes from 0 to infinity, 2 times negative 1 to the n. This thing is just going to be properties of exponents, 3 to the n plus 2. Okay, and that's going to be my final answer. Notice the interval convergence is just still going to be the same, from negative 1 to 1. Whoops, not equals 2. Okay, so it's still going to be exactly the same thing. Okay, now let's do one last problem. Part C. So we have f of x is equal to x cubed divided by 3 minus x squared. Okay, so again, we're going to start off with what we know. Our regular f of x, which was 1 over 1 minus x, is equal to the sum from n goes from 0 to infinity, x to the n, okay? Provided that x, absolute value of x, is less than 1. Okay, now what we have is f of x. So we need to change this f of x so that it looks kind of like the purple part. Okay, so we're going to do the same thing, move the x cubed over. So move x cubed, 1 over 3 minus x squared. Okay, now notice here, okay, well, I need to do a couple things because I need to change this 3 into a 1. Okay, well, one way to change this 3 to a 1 is to factor it out. So we have x cubed over 1, so this guy is nothing's going to happen to it. 1 over, let me factor out a 3. So I'm going to factor out a 3. So now this turns into a 1, but this guy is not going to turn into an x squared over 3 because I divided that thing by 3. Now I can put the 3 on the outside, so x cubed over 3 times 1 over 1 minus x squared over 3. Okay? So now this guy right here now looks a lot like this whole thing. Okay, so now let me go ahead and use the power series representation. So this is going to be x over 3 over 3, x cubed over 3. And this thing is just going to be the sum from n goes from 0 to infinity of x. X in this case is going to be this thing. Okay, it's going to be this x squared over 3 to the power of n. Now remember, I'm plugging in this x into here, so I got to plug in the same x into here, provided that x squared over 3 is less than 1. Okay, so I'm going to box this. I'm going to save this for later to find my interval of convergence. And now let me deal with this guy first. So I have x cubed over 3. Okay, the sum from n goes from 0 to infinity. On the top, I have an x to the 2n. On the bottom, I have a 3 to the n. And let me bring this in the inside. So the sum from n goes from 0 to infinity. I have x cubed times x to the 2n divided by 3 to the first power times 3 to the n. So what I'm going to have is the sum from n goes from 0 to infinity of x to the 2n plus 3 divided by 3 to the n plus 1. Okay, so you can leave it like this. You can also write it as 1/3 n plus 1. So another way that you can write this is 1/3 n plus 1 and then x to the 2n plus 3. So you can write it like that. Doesn't really matter. Okay, now let's figure out what the radius of the interval of convergence will be. So now it's time for this guy. So I have this absolute value of x squared over 3 less than 1. Now I'm going to get rid of the absolute value. So I have x squared over 3 less than 1 less than negative 1. Okay, actually let me do this instead, because then that one's going to look weird. Let me get rid of the square. So I'm going to have, or let me move the 3 over. Know that there's a 3 on the denominator, so I can take that out of the absolute value. So I have 1/3 then x squared less than 1, because I know the absolute value of 1/3 is just 1/3. Move the 3 over, I have x squared is less than 3. And then I can use some properties of absolute values. I can put the square on the outside. And then I'm going to take the square root. Now notice, this is not going to be plus or minus, because if this was minus, there's no way that a negative number is greater than an absolute value. So that way, that means that this is only going to be a positive. Okay, then we can just get rid of the absolute value by making it square root of 3 and negative square root of 3. So my interval of convergence is going to be between, whoops, that's wrong, between negative square root of 3 to square root of 3. Okay.